Hey, welcome back to IED. Today we're talking about properties of geometric solids. Solids are three-dimensional objects. In sketching, two-dimensional shapes are used to create the illusion of the three-dimensional solids. All right, so it is an illusion when we're sketching. They're not really 3D. They're actually two dimensions. There's only actually a height and a width, but they appear to be three-dimensional when we're sketching them. Okay, properties of solids. Volume, mass, weight, density, and surface area are properties that all solids possess. These properties are used by engineers and manufacturers to determine material type, cost, and other factors associated with the design of the objects. Volume is one of these volume equations. All right. Volume refers to the amount of three-dimensional space occupied by an object or enclosed within a container. Okay, so for a cube, our volume is equal to s cubed. For the volume of a prism, the volume equals width times depth times height. For the volume of a cylinder, it is pi r squared times h. R is the radius and h is the height. Mass refers to the quantity of matter in an object. It is often confused with the concept of weight in the SI system. A couple students the other day were asking the difference between mass density and weight density. Well, mass is when we're using things like grams or kilograms. Weight would be if we're using pounds. So there's a difference between weight and mass. It's not just the metric system versus the standard system. Weight, and here's the difference. Weight is the force of gravity acting on an object. All right. Mass refers to the quantity of matter in an object. Weight is the force of gravity acting on an object. So they're not the same thing. All right? I know a lot of times we use them interchangeably, but they're not exactly the same thing. Mass versus weight. Mass and weight are not the same. For example, space and Earth. All right. In space, you're not going to have any weight. Why? Because there's no gravity. But you're still going to have mass. All right, so what we find out here then is weight equals mass times acceleration due to gravity. A lot of times in physics, we won't use the standard system. We'll talk about things in the form of the metric system, and we would say weight, which would be in newtons, and mass, which would be in kilograms, and acceleration, which would be in meters per second squared. So there's another way we can look at weight. Weight could be in newtons. Weight density, all right, is an object's weight per unit volume. All right. Notice down here we have pounds per inches squared. So the volume is still the same from the day we talked about density. We're still using volume, but now instead of using mass on top, instead of it being mass density, it's weight density. So we're using a unit that refers to pounds. It could also be newtons per cubic centimeter because newtons is a weight. Here's some examples of different weight densities. If you don't have these, I'd take 30 seconds to get these written down. We might use these in class. Here's some problems. All right, calculating weight. All right, another equation for weight is we can take the volume times the density. All right, so in this case, they're giving us the weight density. We just have to take it now times the volume. So this right here is a cube-like figure. Check that. Prism is the word I want to use here. Rectangular prism. All right, a rectangular prism. But we're going to take width times depth times height. So that's the equation we're going to use. So I got to find my volume here. My volume is equal to width times depth times height. Well, my width is 7. My depth is 3.5. And my height is 1.5. So my volume turns out to be, my volume is 36.75. And this is going to be, notice that my units are all here. I'm going to guess because they give me this up here in inches, that it's not in cubic centimeters, but it's in cubic inches. Now with this then, that becomes my volume, so my weight can be found by taking my volume of 36.75 and multiplying it by the weight density, 0.098. And now the weight here turns out to be 3.6 pounds. There's the distinction between area and surface area. Area describes the measure of a two-dimensional space enclosed by a shape. So we would find the area of a circle. We'd find the area of a box or a triangle. Surface area, all right, is the sum of all the areas of the faces of a three-dimensional solid. So if we had a box, we would then be finding the surface area because we'd be taking all six sides. Or if we had um, not a sphere, can't think of what this is called. But we would be finding the surface area. We can find the surface area on the sides and then the bottom and the top. A cylinder, there we go. Sorry about that. Okay, surface area of a cube. Well, it's kind of a two-step problem. Surface area is 6 times A, which means if you remember from earlier, in this case, area is S squared. All right, we take the sides and square it, and then we multiply it by 6 because all 6 sides are the same. So in this problem here, to find this area, I'm going to take 4 times 4, or I'll just do this side here, 4 times 4, which is 16. So now that's what A is equal to, so I'm going to plug that up here for A, and we could find the surface area then is 6 times 16, which turns out to be 96. If these were all inches, it'd be inches squared because there are 96 square inches around the outside of this cube. The next one here is a rectangular prism. Find the surface area. Well, we find the surface area by finding the surface area, or finding the area of each one of these. Notice that there are width and depth. The reason they've got 2 in front of all these is width and depth. There's my width, all right, and there's my depth. So what they're finding here, the first one is the top and the bottom because there's the width, there's the depth. That's why there's 2 of them. We're multiplying it by 2. Width and height. There's the width, there's the height. So now they're having us find what you could say is the front, and then the opposite of that would be the back. And then the depth and the height, this is our depth, and this is our height. So we could say this is the left side, and then the side you can't see would be the right. So notice there's 2 of these. So what we do is we find each of them individually, one side, and we just multiply it by 2. So what we're going to do here then is find the area of each of these. Width and depth. All right, width and depth. Well, that turns out to be my top and bottom. So that's 4 or 5.25 times my depth of 4. So that's 5 times 0.25 times 4, which turns out to be 21. Width and height. This is width and this is height. So that's 5.25 times 2.5. And you see 5.25 times 2.5, carry the 1, that turns out to be 13.125. And then the left and right sides, all right, that's my depth and my height. My depth and my height, well, that's 4 times 2.5, and that turns out to be 10. So if I add these up, my surface area equals, all I did is add these numbers up here to get the number inside. Now I got to multiply that by 2, and my surface area then turns out to be 88.25 inches squared. All right, the last one we have here then is surface area calculation for a cylinder. Well, the pi r squared. The pi r squared is simply finding the area of the top and bottom. All right, this right here is the top and the bottom of the can. Think of this as a can. That's our top, and the part you can't see down here would be the bottom. And there's 2 of them. The area of these are pi r squared, and there's 2 of those. Now 2 pi r times h, well, if we start right here, the distance around is the circumference. But if we were to cut it right there and spread that out, that distance around there, if I were to cut it and spread it, we become a rectangle. Well, how do we find the area of a rectangle? It's base times height. Well, that distance around there would be this distance right there, which is our base, and which happens to be the circumference. So this becomes the base times the height. So how do we do it? 2 pi r, they tell us the radius up here is 1.5. So I'm going to take 2 times 1.5 and I get 3. So this becomes 3 times 3.14 times the height of 6. So that's the first part here. Now I'm going to do the second part. 2 pi r squared. So I'm going to say plus, kind of follow my train of thought here. It's going to be 2 times 3.14, and then it's 1.5 squared, which is 2.25. So now I'm going to multiply these up. 3 times 3.14 times 6 is 56.52. That's this first part. Now I got to do the last part, and that's multiplying these. 2 times 3.14 times 2.25 gives me 14.13. I do this middle part here which says to add them together, and I'm going to get 70.65 square inches. That's my surface area. Well, hey, we've gone over the area, we've gone over surface area. Hopefully that was very informational. I'll catch you on the flip side.